Let me turn it off. Okay, pretty much the first week for those two lectures, I emphasize this concept. Just make sure that, oh, wait a minute. I forgot one more thing. Sorry. Hello? Okay, good. So this is what we try to tackle this particular quarter, is looking at the two sides of object-oriented paradigm. One side is actually providing a better way of approaching large program. I mean, how do we actually use that to organize our code, organize our information such that we reduce the chance that we make mistake, and then we can reuse the code that we actually developed earlier to be able to extend the new functionality. That's all good about object-oriented programming. And the other side, which is equally important or even more important, is that in general, we view object-oriented as a connection for us as a information technology to reach out to real world, to see how do I actually be able to capture everything, modeling everything very carefully, and so I can solve a real problem. As you probably saw that in my first lecture, there is a connection between object-oriented programming and artificial intelligence as they were developed in the 1950s. And by the way, some of you might know that artificial intelligence back then in 1950 is actually quite different from what we call the artificial intelligence today. Today is more about applying statistical methods to represent the data, try to dig out the property of the data we're dealing with using variety of mathematical tools. So that's essentially the dominating paradigms of artificial intelligence today. I mean, you can handle text, you can handle video, you can handle all sorts of statistical information. Back in 1950 until probably early 90s, the paradigms in artificial intelligence is actually a little bit different. I just want to ask a question. Any of you here is majoring in cognitive science, psychology, cognitive science? That's what, oh, thank you. Thank you, bro. We have a few. Thank you. And essentially, cognitive science is equal to artificial intelligence at that time. And then when I did my PhD in the 80s, I basically always go to psychology and cognitive science, try to understand how they model a human's brain. How do they model a psychological behavior? How do I actually understand how humans think? So there is a lot of really nice tool developed by cognitive science for us to understand what we mean by intelligence of the human being. I mean, for the past, I should say that for the past 20 so years, it's really driven by the data availability, like Google, for example. That's such that the industry kind of push artificial intelligence into more of a statistical concept. And however, it's my belief at a point they already pushed to the limit, they realize they can actually develop really nice tool to actually make a recommendation or to actually decide what kind of object this is, or understand natural language processing to an extent. But now they encounter an issue about explainability. I mean, okay, this is a good recommendation, but why this recommendation? So we have to go back to social science, cognitive science. So we're actually seeing that this scientific development is always keep coming back. And the thing is that to model that kind of situation, because you have to model a human being, you have to model the object in order for us to dig into a more semantic about those information and those objects and how they can actually represent as information in the cyberspace. That's why just historically how object-oriented was really developed is actually helping us to be able to quickly make those concepts in the real world become programmable. So that's why it is actually very important for us to actually start knowing this tool and be able to apply to solving the real world problem. So that's just want to tell you that there are two perspectives about this course that we try to go over. So last time, for example, we use an example. The first object I show you is longitude and latitude. It's essentially a GPS, the data that help us to understand. And so today we're going to base on that to go deeper to really introduce what I call language construct. Language construct means that some or all object-oriented programming language will provide those kind of features for us to use those features to represent the information, such as the latitude and longitude in this sense. How do we do that? So we're going to talk about, I used this figure already last time. If you're here, if you watch the video, which I'm going to release, sorry, the slide was missing. But I actually drew this picture. This is a abstract view about what is an object. So an object essentially has some kind of internal variable. And in this case, the example is latitude and longitude. That's the two numbers we actually care. And then provide a bunch of interface. That interface might include constructor, which we will actually go a little bit deeper into the constructor today. And also how do you actually be able to make use of those information. And that is the concept we call class. In last time we showed an example of a class GPS. So the next few weeks, I'm actually going through 4 major language construct of any object-oriented programming language. So any object-oriented programming language, they should, one way or the other, have this form: data abstraction, polymorphism, inheritance, and encapsulation. So we'll see that how in C++, those 4 features will be there. So just let you know that the textbook is actually available. You can actually go to the library. I hope you have that hard copy, and then you will see that the syllabus actually include the pointer to the textbook, and you can actually access to that. And there are multiple chapters, and what we are going to cover is chapter 11 right now, which is talk about classes, okay? All the things related to classes. And then we're going to talk about overloading and inheritance and polymorphism in that order. So it's chapter 11 to chapter 14. Those are the most important chapter in this class. And for the midterm exam, is going to be only cover this 4 chapter. By the way, the midterm exam is going to be open book. It's going to be open internet. Okay, so you will see that I'm not going to ask you to remember something. Basically, when I was a student, I hate to remember anything. All right, I'm that kind of student or instructor. So I usually believe it's my responsibility to make sure that it's an exam. You cannot easily do a Google to find the answer. And you don't, even if you spend time trying to communicate with yourself, you don't have time to do that. Because I'm actually going to give you a bunch of challenging questions. And then I focus a lot on the basic concept and critical thinking. Yes. Okay, so there is a link, for example. Let me actually show you the syllabus. Let me bring the syllabus back. This is the syllabus, and inside you see there's a textbook. You see here? And if you click on this one, let me actually turn on the library VPN. If you use this, click the link using library VPN, the UC Davis library VPN, you will be able to access the book for free. You can actually download the chapter as well. Okay? Yeah. Which one?
To the syllabus section of Canvas, then
Okay. Yeah, thank you. Yeah, let's address that after the class. If you have any question about things you cannot access, okay? All right, so there is also, I gave you the link that this link actually provide to the GitHub about all the source code that's actually being used in the textbook. So the textbook is nice, is not just, it's a textbook, it really gives you the program that you can actually run it. I mean, programming language, you probably know this already, is that you really don't learn those concepts unless you really play around the program yourself. Means that you download the program, you modify a few lines to see, you will experience errors and warnings and things like that. And then unless you have that experience, you won't learn well. Okay, okay. So I should probably say this. I like to break this as a obstacle for learning programming language for many of us, including myself. Okay, I assume you have taken courses like ecs36b, and also maybe you took a course that's equivalent to that in another college, and then you transfer over here. How many of you have experience, just raise your hand, that you see pages of error and warning message when you try to run the program? How many of you have experienced that? Okay, some of you. All right. So what's your feeling when you saw this message? What's your feeling? Very exciting, very happy.
I just was not okay.
All right. So usually a normal person, when you look at the message, you feel joy. Okay, you feel relaxed. You feel the world is actually making really good progress. No, that's exactly the opposite. Okay. When I saw this message, I would like to throw away my computer. I said, wait a minute. I spent so much time to give me that, a lot of this error message. So, okay, so for this course, I really want to, the first thing I want to tell you is that you should really feel joyful when you saw the error message. Because either those error messages can be easily resolved, or those error messages try to teach us something. So to learn from the error message, the warning message is very important. We'll see a few examples later. The second thing I do want to tell you is that the computer programming language until today is very weak in communicating those error messages. They usually give you way too many information such that you cannot easily digest and narrow down to exactly which part you miss, or which, in a lot of cases, just one parenthesis, one curly bracket, one single quote, one comma. Okay, that's actually so common. It's a so small mistake, and then why the program cannot work. Okay, and the thing is that I remember that there is I help a student try to debug a program for a long time. He tried everything, I tried everything. It doesn't work. And then I realized it's just a one variable misspelling, about 2-letter twisted. And for that reason, that actually not variable, it's a string in the what we call the constant. So compiler didn't detect anything mismatch. But the thing is that logically it cannot work. So sometimes it's really it's really challenging for a programmer that when you saw this error and warning message. But this quarter, I really want to not just make sure you understand it's absolutely okay to receive those messages. Furthermore, I want you to actually pay attention to those error messages. How do you actually quickly identify the most critical information and learn from those experiences. Okay, so that's why the programming is very important. And then the text message, the example that I use in the textbook is all actually recorded in this GitHub link as well. Okay. Okay, so now let's actually just review a little bit what we did at the end of last Friday. So we say this is the graphical view about what an object looks like. You have a method, public method, and then you have the attribute inside, which is private. And sometimes you might include the other object, which we call it a composite object, means the object might be include another object. But anyway, syntactically, when you actually represent, it will be looks like this. So syntax, so when we learn class, let's start with something very simple. If you actually understand this syntax, understand the red character in this picture is really just syntactically, how do you actually specify a class? Once you learn that red part, and then you just make the rest of the class more and more complicated as you learn to solve a more complicated problem, and you learn from that process. But the basic concept is just that red. You just specify a class, has a class name. And then in between this pair of curly bracket with a semicolon ended, inside there, you have two different sections. One is private, one is public. For public is essentially what you can access from outside of the object, and private is everything else that you want to keep to yourself and you want to protect. That's why later we'll learn the concept called encapsulation, is that we want to encapsulate the data. You really want to protect the detail in here, but you only expose yourself to the outside. All right, so that's the basic thing I want you to learn. And a view looks like this is essentially saying that, well, you can have the method, which is provide different kind of what we sometimes call interface, sometimes called member function. And those methods, some of them will be public, but some of them could be private as well. Okay, just to let you know. And similar for data attribute, it could be private or it could be public. All right. All right, let's see some example. I'm actually going to just show you that this is an example. The reason I want to show you this is an example called class box. So this one is actually the example directly picked up from your textbook, chapter 11. All right, so I'm not going to go in this detail, but just look at this structurally, but not looking at the detail. You see that there's a private, instead of longitude, attitude, it's a box. So a box has a length, has a width, and height. Again, just like a longitude and latitude, it's a 3 double. I actually specified there. Okay, so those are the private. And then it has something called constructor, which we will show you the example. So the constructor is actually a function you're going to call automatically when you actually create an object. So this is the number one concept we need to learn for this new class is that constructor. What is a constructor? Constructor is the function automatically get called when you try to create an object. And of course, over here, you can start guessing what is the constructor doing. Inside the constructor, it's really just try to set the value, to set the private value when you actually say create a bank account. And of course, that constructor is going to set your balance to be 0 initially. I would love to have somebody actually make that mistake in the bank, say when I open an account, it will put $1 million in my account directly. And of course, that's not happening if you're doing things correctly. That's what constructor is, a $1 million benefit over there. Okay, and then you have what we call member function. In this case is the volume of the box, which is, you can see that when you call this function, it's just, it does not allow anybody from outside to directly access the length, width, and height. But instead, when you call the function, the member function volume, which is public, it will actually times those three together and return that value, and that value is a double. So that's the member function. So this is the example you can play around. It's a very simple example, the textbook use box to do a lot of interesting things. Okay, and the thing is that you can see that in this example, I actually including the code inside the class definition, but alternatively, which is a better way to do this, is actually doing like this. So instead of having the code of the constructor and the function in the class definition, I actually make a separate. What do I mean by make the separate? It means when I define the class, I only have the what I call the function header, the function signature, which is function signature means that the return value type, the name of the function, and the input parameters and the type. That's called function signature. So I only include the definition in the function signature, and then I use another file to actually finish the implementation. So let me just tell you that what's the difference is that the rest of the class definition is actually defined, the structure, that's the specification of the class, but the function body itself is sometimes we call it implementation. That's how you actually implement how this file. Let me actually ask you a question. I like to, instead of just tell you something, I want you to think about, because you have some programming experience. Just use this two examples. One example is this. I actually include the implementation and the class definition together in one single file. And the other way is I actually make a separate. The declaration about the class is being separated from the implementation of the class. So they're both in the class box. By the way, both the code is actually in the GitHub repository. So my question to all of you, which way do you think is better and why? Think about that for a few seconds. I'm actually going to turn on the light. Why don't we do this? Why don't we have a little bit discussion, like a 2 months, not 2 months, 2 minutes with your neighbor? Okay, try to turn around and talk, and for 2 minutes, and just discuss why you think one way is better than the other and why. Okay, why don't you go ahead, talk about this. Yeah. Okay. This is the okay. All right. My 2 minutes went very fast, so it's already time up. Okay. So any group would like to report? Let me see your show hand. Which I don't want you to show hand. That's kind of not the encouraging way I'll deliver my message. Okay. All right. Any group want to share which way is better and why? Yes, please.
Separating files. The first thing is for compilation. If I make a change in one file, I don't have to recompile everything. And also for the interface, I can have the same function slightly different in two different programs. So it would adapt to my different needs in each program. Okay. And also it's more organized than me to go through if there's a mistake.
Right. And everybody heard about that? Everybody agree, or do you have any other thought on this? Okay, so the second way is better because if you want to make some changes, you don't have to change everything because it's separate, right? You have a file here, then you have the source code, you can change that. And even though he actually point out the other issue is that sometimes one have the same interface, the same class definition, but I might have different implementation depending on your function. So we will see that how we can compile and build into different implementation. In fact, the second way is the dominant way of doing this. I mean, for example, when Microsoft or all this company, when they want to release the software, have you noticed they don't want to release the source code? They don't want to release the source code because if they give you the source code, you actually be able to get a lot of the intellectual property from their source code. So what they did is they only release you the interface part. They release the interface, and for the implementation, they actually compile something into object code, the binary code, which is technically is hard, not impossible, but hard for you to reverse engineer to actually see the original source code. So that quickly got ourselves into another debate about how we protect the software intellectual property. But the thing is that if you look at the industry when they release the software, it's always release the what we call the header file. So this part is called the header file sometimes. And the thing is that this header file can be shared by multiple source code. And the thing is that when you release, you just release the binary code and the header file. And then that will protect your information in a reasonable way. So thank you for the discussion. All right, so now you actually understand, then that's, oh, let me turn on. Then you can actually call this function. And this is the one important reason of why you want to do the separation, because if I don't separate, I actually need to include the whole thing. And sometimes you got into trouble because you actually include something multiple times. That's why later you will see I use a lot of this kind of preprocessor symbol try to protect that from happening. But anyway, over here, you can see this is program on the box, which has the include the box.h. And then I just directly call this function here and there. And then this is the corresponding between the .h and the .c program I just showed you. By the way, this one is exercise chapter 11.018.cpp in the textbook. And you can see that when I make the call, I actually first I call the constructor, and then I call the function volume. So you can see that over here in the class definition, you have that constructor and you have that volume. They match together. And this is the program I gave you last time. I gave you last time the same thing, right? I use a GPS. So you can see that this part is GPS.h. Sorry, this part is this part is GPS.h. The GPS.h provides the definition, and essentially it has constructor over here, GPSDD, and it has a function, member function called distance. And inside that, the main function, if you actually spend some time with this program released last Friday, it has constructor being called twice, GPS Davis and then GPS current. And then when I call it, I just say std cout, and then I call GPS Davis.distance and use that current. All right. One thing I want to emphasize, this is at least very true in a programming language like a C and C++, is that how do I actually match the function from the caller to the callee? It's actually based on a concept called function signature. Particularly interesting is you can see that in my definition, I have two functions. They both call GPS ED. In fact, I have a two constructor in this sense. So one of the constructor doesn't take any argument. The other constructor take a two argument. That's how we use this function signature. So I just want to say it once, so make sure we're on the same page. Is what is the function signature? How do I actually match the right function implementation? It's always about the definition, and then we have to link to the right implementation. So when you call, it's really function name, the three things: function name, the return data type, and the input argument and their data type. So this has to be completely matched, with some exception, which I will show you in a minute. Okay. Any question? Okay. I mean, the next slide, I'm just flashing to just tell you it's the tedious. In my opinion, it's not that important, but I want to tell you that people does make the this different kind of way of doing construction. So you can see that line number 8 is a different notation. Both work. Both are the invocation of constructor. And the line number 8 on top is the traditional way. So it actually looks like I'm actually calling a function, and that function is a member function called constructor. So that's why I call it box, and with parentheses, and with 3 arguments. That's the traditional way. And starting from 2011, around 2011, the C++ community come up with something called bracket initialization. So that's why they actually come up with a different notation specifically for constructor. So instead of calling constructor explicitly, they use a bracket to actually put the 3 arguments saying that, okay, this is actually, we want to initialize the variable. This is called bracket initialization, but these two, semantically, they are exactly the same. They're both actually going to call the function. That's why I said sometimes to learn this is no more important than just understand somebody else's code. Okay, when you write it, you can actually use either one of this, but you need to know this because you need to understand somebody else's code. Okay. All right. So just let you know that bracket initialization, the C++, remember last time I actually, when I did this line, C++ minus std, I can specify which version of the C++ compiler that you will be using. So essentially today, this minus std flag, you can actually replace with C++ 98 and all the way to C++ 2a. So what I'm saying is that if you use an older version of the compiler, it will not recognize bracket initialization. So that's why I always prefer today, in this class, you should use, I actually will recommend you use C++ 14. It seems to be C++ 14 is new enough, but it's stable enough. That's why it's a sometimes we just have so many different versions of the C++ compiler. So just let you know. All right. So I'm actually going to show you some example right now. Okay, I'm running out of time a little bit. Let me see, how many minutes do I have? Yeah, I have 13 minutes. Okay. So let me go back to this code. So last time we have this piece of code, right? And I have this GPS location, and then I call this function called distance. And I actually changed the code a little bit such that I can actually do this. First, what I changed, let me actually show you my screen. Okay, this is the code I want to show you. Okay. Wait a minute. Yes, okay. The first thing I actually changed in order for demonstrate this issue is that I actually changed the interface to remove the pointer. So now the distance, instead of doing a GPS DD star, which is represent pointer, now I'm just call by value. Just put GPS DD directly as a function signature. So I removed the star for this version of program. All right, and then what I did is the program, you can see what I did now, is that I actually changed the program to declare another variable I call double distance calculated. And then I actually just call the function GPS Davis distance current, which is the current is the one I actually got it from here. And I just got a distance calculated. And then I use stdcl to actually print the value. So functionally, this program is exactly the same as what you have seen last Friday, except now I declare one extra variable for me to first send the value return from that distance member function to this variable, and then I want to print it. Okay, that's the only thing I did differently. And now I want you to give you a challenge. So now I actually have a 4 different way of implementing this line. So I have that function called double distance calculated. And then I have a 4 different way of actually calling the function. So the first is, as I said, is just saying that GPS Davis dot distance current. Okay, that's the first way. The second way, I actually replace that with GPS DD using bracket initialization and directly use the function A to F to actually do that. So I kind of replace that whole thing with whatever. Let me just remind you what that code is coming from. If you actually look at the code here, you see that this piece of code here is a bracket initialization. How do I actually get current? It's a bracket A to F, argument 1, argument 2. All right, so I basically replace that into the code. Okay, that's the second way. And the third way is if you compare the second way and third way, what's the difference? This way and this way, what's the difference between these two? The difference is that I actually have without the GPS DD. Without saying GPS DD, I just basically put the bracket over here. I just put the parameter part about that particular constructor put in there. And the fourth way is even worse. I actually remove everything. I just leave a pair of curly bracket. Okay, so my question to you, I show you 4 different ways. Which way do you think it will work? Which way do you think the compiler is going to give us error?
The second one?
We have a hand in the back. Yeah.
Yeah, I think the first and second one will work.
Okay. And the third one, fourth one, it won't work?
No, because in the third one, you don't define like any class to be
Right.
initialized. But in the fourth one, I think that's just like the straight.
Right. Good. Any other answer? Okay. This is, in general, my answer to this kind of question. If somebody asks me this question, Guess how I'm going to answer? I'm actually going to write a program to run it, to see how that works, right? So let me actually try to run it. Okay, you can see I have this program here, Control X, Control C. So I have this program, right? Let me just show what is test gps.cpp. It's a program, those 4 different ways. I put it there. Let me actually check gps.h, make sure yeah, everything looks good, GPS-C. Okay, so I'm actually going to do this. By the way, I wrote a make file. To do that, which I hope the first discussion session, the TA is going to teach you how to do makefile. But essentially, this is the makefile that's actually try to replace that G++ program. So I'm going to type just a make. What error message? I said I love error message, right? Okay, I know what happened because I removed the namespace. This is a test program. Okay, fine. I was actually modified here and there for the namespace. Okay, this is the place I have to use std, 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 std. Okay, I'm going to use this one. I'm going to explain namespace next time on Wednesday. So I'm going to type make. Okay, all 4 actually they work. The answer is all 4 work. But let's try to run the program to see if this makes sense. I run the program, I have to run the program with a parameter. Here, this is the coordinate of Paris. Okay, so I have a 4 printout. The first 3 give me exactly the same answer. And the 4th one give me a different answer. Much larger in terms of mileage. So let me actually explain to you why your instinct is correct. The first 2 is clear, but C++ plays some trick such that the 3rd one and the 4th one will work as well. But I will explain to you how do you actually overcome that trick. Let me show you this one. Okay, let me actually use the program again. So let's actually look at this 4 program. The 4 way of expressing it. So I guess you understand the first one and the second one, it works. But the thing is that the 3rd one, I didn't actually provide the class name. I only provide the parameter. So C++ implicitly, they sometimes play smart. They want to do this kind of automatic conversion because they know if you want to call the constructor, I only have 2 constructor available. One take a 0 parameter, one take a 2 parameter. So essentially C++ compiler, I'm not sure this is good or bad. You can think about that. In fact, I actually strongly argue against it, but some people think it's convenient, is that if you actually want to call the distance, and I know the distance is going to take an object called GPS, and then I'm actually going to interpret this part I highlighted as an invocation of the constructor to that particular object. So it implicitly, I assume, is an invocation of the constructor, and therefore, I'm actually going to match this into whatever constructor that has that kind of input initialization, bracket initialization. So this one will actually invoke exactly the same constructor as this one, because the compiler say, yeah, the distance is expecting the GPSDD. And similar for this one, I actually didn't put anything. Remember how many constructor I have? 2 constructor, one take a 0 argument, one take a 2 argument. So this one is going to invoke the constructor with 2 arguments. This one is going to invoke the constructor with a 0 argument. That's why the answer is going to be different, because that constructor initialized the distance, the latitude and longitude to be both 0. That's why the distance is bigger. Okay, so I don't have time to, otherwise I would like you to think about why programming language want to design that flexibility to actually, sometimes it's convenient, but sometimes confusing us. Give me one example. How do I actually fix this? To fix this is very simple, just let you know. I go to gps.h. I'm going to add a keyword. Over here, I will say explicit. Over here, I'm going to add another keyword called explicit. If I actually add explicit, meaning that the constructor cannot be revoked, like the way I do that implicitly. If I make this change, and then I do a make again, you can see that now it's coming out with the arrow. It's saying that this line, you cannot do that. Because why? Because the GPS is explicit. That's why I said looking at the arrow message is important. It's actually telling you why. This actually tells you the arrow, it says chosen constructor. For the compiler, instead of look at every single information, it's actually telling you this. Explicit. That keyword is going to make the things generate that error message. So that's why the whole page, look for those answers to help you to deal with that. Okay, I just want to tell you before you go one thing about homework assignment. I'm sorry, I'm running out of time. I cannot show you the demo for homework assignment number 1, but the homework assignment 1, the real due date is actually later, 3 weeks later than the given due date, because initially I want to offer the time extension for those who actually never learned C before, okay? But I feel if I give them the deadline, it might as well give everybody that extra time. So you should finish by the given deadline. So the thing is that you won't have a penalty by the second deadline. Okay, just to let you know that. Do we have discussion today? No. Okay, we don't have a discussion today, but I will stay here for 1 more hour. You can ask me any questions you want.
So the second deadline is the 28th, right?
Exactly.
Okay.
Yeah. Give me 1 second. Let me stop recording.